Welcome to my project bazaar. Let us discuss about title of our project. Our project title is NDCMC, a hybrid data collections approaches for large scale WSNs using mobile elements and hierarchical clustering. Let us discuss about the abstract of our project. In order to collect the information more efficiently, wireless sensor networks are partitioned into clusters. Clusters provide an effective way to prolong the lifetime of wireless sensor networks. Current clustering approaches often using the two methods: selecting the cluster heads with the more residential energy and rotational cluster head periodically to distributing the energy consumption among the nodes in each clusters and extending the network lifetime. However, most of the previous algorithms have not considered the expected residual energy, which is the predicated remaining energy for being selected as the cluster head and running a rotate. In this project, a position-based clustering and energy-based cluster head selection approaches with an extension to the energy predicated has been proposed to prolonging the lifetime of the wireless sensors by evenly distributing the world work. The proposed clustering method follows the basic principles of AODV. The NS2 simulation results shows the proposed approaches is more efficient than other distributed algorithm. It is believed that the technique present in this process could be further applied in the large scale wireless sensor networks. Let us discuss about objectives of our project. To reducing the energy consumption, to increasing the network lifetime. The main objective of our project is efficient cluster communication using multi-hop routing algorithm and optimal path finding algorithm for wireless sensor networks. Let us discuss about flow of our project. First one is a network formation. The networks are formed within a given range of the sensors. Nodes are grouped automatically depends upon their radio waves. Agents are formed for a group registration. The simulation work has been done within the NS2. The simulation nodes are randomly distributed within the network field of the size of given region. The TCP is used to establish the connection between the source and the destination. Then the FTP are randomly chosen the different source and the destination connection. Next one is an position based clustering is done here. The cluster formation takes place using the cluster algorithm. Here the position based clustering is done. Then the cluster head selection is based on the energy of the node. The cluster head is used to monitoring the member of the cluster nodes. Each cluster head containing the every node position, speed of every history of the member of the node. Then next one is an labor node estimation, on-demand reactive protocol that using the routing table with the one entry per destination. When the source nodes need to finding a routing of the destination, it start routing discovery process based on the floating to the location based destination nodes. Upon receiving request packet intermediating the nodes, updating their routing tables for a reverse routing to the source. Similarly, the forward routing to the destination is updated upon the receiving request reply. The packet oriented either by the destination itself or any other intermediate node that has a current routing to the destination. Then next one is a multi-hop routing. The multi-hop routing is used to in the proposed method for constructing an optimal path for transmitting the sender data to the destination. The nodes with has to the data to transmitting a data is called a source node. Such node checks for the next best hop to the transmitting the sender data towards the destination. For finding the next best hop, for finding the next best hop, the routing request messages is sent to all the neighbors nodes. The routing request sent to all the intermediate node between the source and the destination. Finally, we finding the performance evaluation. Here we calculating the packet delivery ratio, throughput, energy consumption and delay of our network. Let us discuss about the output of our project. First, open the terminal window. Then type cd space NDCMC. The cd space NDCMC is used to change the directory. Now the directory is root, then change into NDCMC folder. Then type ns space main.tcl. This command is used to run our main file of the project. This is an NAM console and it is a out.nam window. Here we displayed the output of our project. Then this is a zoom in button and this one is a zoom out button. Then this is rewind button, playback button, stop button and forward, play forward button and fast forward button. Now I play the project. Here the base station and the relay node is deployed. The base station is deployed in a static way. Then the cluster is produced on a dynamic node creation. Then position based clustering is done here. Then cluster head is selected on energy based. The relay nodes move to the near the cluster head and collected the information. Then near the base station, near the cluster head, collected the information and go to violet color cluster head. Then collected the information. Then the relay sends the communication to the base station. Now I run the X graph of our project. The X graph space thr.xg. This command is used to display the throughput of our project. Then X graph space delay.xg. This command is used to show the delay of our project. Then the cluster head is based on the energy. Here we calculating the each and every node updated energy of a node for each time. Then we calculating the routing table path. The routing table algorithm is used to printing the node and the current time, then destination node, then best next hop, the number of hop, then sequence number and expire time and flag value. For example, the 3 node in current time is 1.5094 time. The next destination is a 5. The next best hop is a 5. The number of hop between the source and the destination is 1. So the sequence number is 4. Then expire time is 7.509. Then flag value is 1. The neighbor table is used to find the node and neighbor node, then x-axis of the neighbor node and y-axis of the neighbor node, the distance between the source nodes and the neighbors node. Thank you for listening. Our demo is completed.